Good morning or afternoon whenever you're watching this. This video is to finish going over section P4 on polynomials. So the first thing I want to revisit is starting on example 7, which is on page 38, on multiplying radicals using FOIL. We did this last class, but I just want to do another example. So this is the try this problem. It's 2 root 3 minus 1 times root 3 plus 2. So the way we're going to do this is we're going to FOIL like normal and then remember how our square roots act with one another. The first step would be to multiply the first things together. So you're doing 2 root 3 times root 3, and we'll simplify in a minute. The outside term would be 2 root 3 times 2. The inside term would be negative 1 times root 3, so we have minus 1 root 3. And finally, the last term would be negative 1 times 2, so it's minus 2. Now we get to simplify and combine like terms. Remember that anytime you have a root times a root and the radicand, the number inside, is the same, the roots are basically going to cancel. So that's 3. So we get 2 times 3 plus 2 times 2 root 3. Treat this root 3 as if it's a variable. So really we're doing 2 times 2, which is 4, and we have 4 root 3's, minus 1 root 3 minus 2. Now, we're going to get a number term here, a number term here that do not have roots, and then we're going to get a root term here and a root term here. So we're going to combine the rational and the irrational numbers. So 6 minus 2 is 4, and then 4 root 3 minus 1 root 3. We have 4 of something minus 1 of something, so we have 3 of that thing. So my final answer would just be this, 4 plus 3 root 3. Okay, moving on to example 8. This is on finding special products. You really need to be comfortable with having those memorized. We've already talked about how to do that. But you need to recognize, for example, 2x plus 3, this is the first one, squared, is not the square of 2x and the square of 3. You need to, if you don't have this memorized, you need to rewrite this as 2x plus 3 times 2x plus 3 and FOIL that out. But hopefully you have your special products memorized that says take the first thing and square it, so this becomes 4x squared. Then the middle term comes from multiplying these two together and doubling it. So you get 6x, but double that, you get 12x. And then the last term comes from squaring the 3. So you should be able to jump straight to the answer. If you FOIL, like I said, if you FOIL this out, you're going to get the same answer. Let's see. The one that I really want to look at is stuff like example D, and we already did one of these. We might have done this one in class, actually. 3 minus root 6 times 3 plus root 6. You have to get really good at recognizing these type of special products where we have the same number plus and the same number minus. The answer to this is going to be the first term times the first term, which is 9. And then we're going to get minus the second term times the second term. So basically we get our F and our L out of the FOIL, and the O and the I terms are going to cancel each other out. Root 6 times root 6 is just 6, and so 9 minus 6 is 3. Okay, so now what I really wanted to get to is example 9 and talking about rationalizing the denominator. We did talk about how to rationalize when you just have a root in the denominator, but what do you do if you have a term that is plus or minus? So before we do that, let's talk about conjugates. is really going to be easier to show you examples. 2 plus root 5 has a conjugate of 2 minus root 5. 1 plus 2 root 3 has a conjugate of 1 minus 2 root 3. Hopefully you can see the pattern. All we're going to do is change the sign that's in between the number in front, that's a whole number, and then the number that's attached to the square root. So for example, if this was 3 minus root 7, the conjugate would be 3 plus root 7. Okay, why does this help us out? The reason why we're going to use the conjugate is actually going back to this example D. If you look at this example, when we multiply two conjugates together, because 3 minus root 6 and 3 plus root 6 are conjugates, the outer and inner terms of FOIL cancel, and we're going to get an integer plus or minus an integer, and we're going to have an integer answer, which means we've gotten rid of our square root. When we're trying to rationalize the denominator, that's what we're trying to do. We're trying to get rid of the square root. So to rationalize, we're going to multiply numerator and denominator by the conjugate of the denominator. And remember, this doesn't apply if you just have the root. This only applies if you see an addition or subtraction in the denominator. So we'll do a few examples of this. The example in the book is 3 divided by 3 minus root 6. And we've already done this, actually, in example D. So what we're going to do is we're going to multiply numerator and denominator by the conjugate. Well, the conjugate is 3 plus root 6. And like I said, don't forget the numerator. When you're doing this, make sure that you're using parentheses, especially around the numerator, because if you have a negative somewhere, you need to make sure you distribute that negative. You also need to make sure you're distributing this multiplication. So I'm doing 3 times 3, which is 9, and then 3 times root 6, which is 3 root 6. That's the numerator. Now I need to work on the denominator, but I'm going to use the fact that I've already solved this one. I get 3 times 3, which is 9, minus root 6 times root 6, which is 6. 9 minus 6 is 3. This is the example above. We've already done this work. Now, what I have here is correct. However, this can be simplified. And the reason this can be simplified is because in the numerator, I can factor out a 3. This is really 3 times 3 plus root 6. And so what happens is these 3's that are multiplicative factors cancel, and I'm left with 3 plus root 6. Another way to look at it is back here, this and this are both divisible by 3. You have to have both of them divisible by 3. If one of them is divisible by 3, that is not enough. Okay, let's see another example. We'll try this. 2 divided by 2 minus root 2. First step is to figure out the conjugate. Well, the denominator is 2 minus root 2, so the conjugate would be 2 plus root 2. Apply that to both the numerator and the denominator. And let's put some parentheses in here. Remember that your fraction bar is a grouping symbol, which means that the numerator and the denominator need to have parentheses around it. Now you're going to distribute this 2 and multiply by both parts of the conjugate. So 2 times 2 is 4. Again, we're working on the numerator right now. 2 times root 2 is a positive 2 root 2. And now we need to work on the denominator. If you want to do work off to the side, that's fine. But note that the denominator does not go away. It doesn't cancel. You don't want to just write the numerator. What does cancel in the denominator is the root. So I'm going to get the first times the first, which is 4, and the last times the last. And normally we would have outer and inner terms, but I know because of my special products, they're going to cancel. I get minus, and root 2 times root 2 is just 2. So my denominator is 2. And if you notice, both 4 and 2 are divisible by 2. This is going to happen a lot when you're dealing with rationalizing the denominator, but it will not happen every single time. So don't get too happy. Like, for instance, if this number here was a 1 or a 5 or any odd number that's not divisible by 2, you could not cancel a 2 out of the 4. You need to have both terms divisible by 2. So this is really 2 plus 1 root 2, and I don't have to write the 1 in front. If you need to factor this out and write it as 2 times 2 plus root 2 divided by 2, and then cancel the 2's just for safety, go ahead and do that. Okay. The last thing in this section is division of polynomials, and I don't want to spend a ton of time on this. I want to show you something that's not in the book called synthetic division. You should know how to do division of polynomials, but like I said, we're not going to spend a ton of time on it. When we're dividing polynomials, we're going to actually use the same method that you learned in elementary school. So just remember, if I was trying to do, let's see, 28 divided by 3. Let's actually make this a little more challenging. Let's say 282 divided by 3. The first thing you would do is figure out how many times 3 goes into 28. Well, 27 is 3 times 9, so I would put a 9 here, do 9 times 3, which is 27, subtract that, and I get 1, and you carry down the 2. I've realized that this is, a long time ago, but you should remember how to do this. 3 goes into 12 4 times. 3 times 4 would be 12. Oh, and I picked a number that doesn't, or that does go in evenly, and you get 0. In this case, 0 is the remainder. It's all right. So I could say that 282, the number I was trying to divide, equals 3, the number I was dividing by, times my answer, 94, plus my remainder over the number I was dividing. Now, normally we wouldn't write 0 over 3 because 0 over 3 is just 0. But what if we had a fractional part left over? We could keep dividing to get decimals, but what if I don't want to do that? So just to illustrate what I'm trying to say, let's do 283 divided by 3. Well, it's going to be the same, or same process. We're going to get 27 minus 1, we get 13. 3 goes in 13 4 times, we get 12, and we get 1 left over. So I could write this, 283 is equal to 94 times 3 plus a remainder of 1 out of 3. I'm just putting the remainder over the thing I was dividing by. Now I could keep dividing this out and I would put a decimal place here and 10 and I would get 3 and I'd keep going and I'd notice a fraction 0.333 repeating. Well, guess what? This decimal part here is actually whatever this fraction is. But we're going to leave it as a fraction. So now let's see how to do the same thing with polynomials. And let's do 6x cubed minus 9x squared plus 12x divided by 3x. So just like we did before, we're going to set this up where 6x cubed minus 9x squared plus 12x is all inside of the division symbol. And then I'm going to put a 3x outside. Then you need to figure out, well, how many times does it go in each part? Well, 3 goes into 6 2 times. X goes into x cubed. What you're really doing is x cubed divided by x. And that's x squared, because x squared times x is x cubed. And I get 0. Carry down the minus 9x squared. And we're going to do the same thing again. So now figure out how many times 3x goes into negative 9x squared. 3 goes in negative 9, negative 3 times. X goes in x squared, x times. And then multiply those together. I get negative 9x squared. Next, add these, subtract these. I get 0 again. Carry down the 12x. And now see how many times 3x goes into 12x. Well, 3 goes into 12 4 times. X goes in x 1 time, so I just get 4. So my answer to this division problem is the polynomial 2x squared minus 3x plus 4, and I don't have any remainder. Let's do another one that does have a remainder. Let's see. Let's do x squared minus 3x minus 9 divided by x minus 5. I could write this as the fraction x squared minus 3x minus 9 divided by x minus 5. But that doesn't really help me too much because I can't factor the numerator. So we're going to try to divide this out. Okay, so this is a little more challenging when you have something that has two terms that we're dividing by. What you're going to do is look at the first term and see how many times it goes in. So x goes in x squared x times. And then what I'm going to do is multiply this x by both terms in x minus 5. So x times x is x squared. X times minus 5 is minus 5x. And here's where parentheses are important. I want to subtract this entire thing. Notice how the x squareds are going to cancel. And really I'm doing a minus a negative 5x. So I'm adding 5x to negative 3x, which is a positive 2x. Carry the negative 9 down. And now I want to see how many times does x minus 5 go into 2x minus 9. Again, look at the x's. X goes in 2x 2 times. And now take this 2 and multiply by x minus 5. 2 times x is 2x. 2 times negative 5 is negative 10. And I'm going to subtract this in parentheses. The 2x's cancel. And again, I get minus a negative, which is really plus. So I get positive 1. This is my remainder. And I have to know what to do with my remainder. So my answer to this problem, polynomial divided by polynomial, is the thing that I had on top, x plus 2, plus my remainder over the thing that I was dividing by, x minus 5. So I get this expression that has a rational term based on my remainder. These problems can be difficult, and a lot of times I prefer to use something called synthetic division. And I'm going to show you how to do this, but it may be confusing for some of you. And so if you don't like this method, just keep on doing this the other way. So here's how you set up synthetic division. I'm going to use the same example just to illustrate what it is. If I'm dividing by a binomial term, like x minus 5, what I'm going to do is take this number that's here, and I'm going to change the sign. And the reason why is because this is a root. Remember that when we set x minus 5 like not equal to 0, the sign changes? Well, that's really what's going on. I'm not saying that it can't be 0. Well, actually I am, because I don't want to divide by 0. So what I'm doing is I'm taking this number, figuring out what part of my domain, what's my root here? Well, that's 5. Then what I'm going to do is I'm going to take all of my coefficients in front of the x's in x squared minus 3x minus 9. So the first coefficient is 1. I'm going to put a 1 here. The next coefficient is negative 3. And the next number is negative 9. I'm just dropping the x terms. Now there's a procedure that we're going to follow. You're going to take the first number and just drop it down. Then you're going to multiply the 5 times the 1. And when you multiply 5 times 1, you get positive 5, and we're going to put that right here. Then you're going to multiply negative 3 times 5 and put that number below. Negative 15. Sorry, excuse me, I should be adding, not multiplying. Let's go back. I'm going to add negative 3 plus 5, and I get 2. And now I'm going to multiply 5 times 2 and get 10. Add negative 9 and 10 to get positive 1. And here's how this helps us. This last number is always going to be the remainder. And then the other numbers are going to be coefficients of x, where the last one does not have an x term. And then I move up to higher power. So this is 1x plus 2. Well, look at that. This is actually our answer. So my answer is this, x plus 2, plus 1. And then I have to know how to write this. It's always going to be this number over x minus this number, which is basically this term that we started with. And that's the same expression we had above. One thing I do want to show you with synthetic division is, what do you do if there are quote-unquote terms missing? And this example is in your book. It's example 10D. And if you like the other version of division, you're going to notice in your book that it says 0x squared plus 0x inside of the division symbol. So I want you to take a look at that. I'm not going to write that out here. I want to show you how to set up the synthetic division, if that's your preferred method. So to set up x cubed minus 8 divided by x minus 2, remember I'm going to take this number without the minus sign. So if it was plus, it would become minus, but it's minus, so it becomes plus. And then I'm going to take the polynomial that I'm trying to divide out and put all the coefficients. Well, the coefficient of x cubed is 1. The coefficient of x squared is 0 because there are no x squared terms. The coefficient of x is 0 because there are no x terms. And then negative 8 is the coefficient of x to the 0, which is the single term. If you are a person that needs to write out kind of in small just to kind of keep yourself organized, then you can do that. So now let's go through the process. It gets very fast when you get comfortable with this. You carry down the 1, multiply 2 times 1 is 2, add the column, multiply 2 times 2, add the column, multiply 2 times 2. Oh Lord, I did 2 times 2 is not 2. Good morning to me. Let's revisit that. 2 times 1 is 2, add the column, you get 2. 2 times 2 is 4, add the column, you get 4. 2 times 4 is 8, add the column, you get 0. Good. I kind of like it when there's a remainder of 0, because then we don't have that fractional term. So now we have to translate this. This is my constant. This is my coefficient of x. This is my coefficient of x squared. So my final answer would be 1x squared plus 2x plus 4 with a 0 remainder. And if you look in your book, that's the same answer that you get. So what that means is I can write x cubed minus 8 as the thing I was dividing by, x minus 2, times my answer, x squared plus 2x plus 4. This is useful if you know one of the roots and you're trying to factor out an expression. It's something you might use in future math classes. But like I said, we're not going to spend a ton of time on this. You should either know synthetic division or what I'll call old school division, what you learned in elementary school. So that's kind of a wrap up of P4.